Welcome to our presentation at the Photonics Plus event portal and at APEC's YouTube channel. Let's speak about broad bandwidth straylight suppression with ultra-black coatings. I am Alexander Telle. I am the CEO of ACM, the German subsidiary of ACKTAR. ACKTAR is an Israeli technology company, and we are specialized in the development and application of ultra-black light absorbing coatings and coated foils. There are three general applications for our products. You can use them to suppress stray light or to absorb laser power, or even to create high emissivity surfaces. We are active in the wide field of photonics, and with that in most of the technical markets like industrial vision and sensors, life science, analytics, medical, lasers, semiconductors, and also space. Let's start with answering the question, why shall I use black absorbing coatings at all in my application? And my answer is clear. You want to enhance the signal to noise ratio, or you want to increase sensitivity and contrast, or improve the image quality in the optical system, or you want to boost the beam power and the beam quality in your laser system. Now you could say, I have used black anodized aluminum since decades. Why to invest in specific absorbing coatings? My answer is because your application deserves a better performance, and it might not only be in the visible, but also in the UV range and or in the infrared wavelength range. Take a look at these diagrams that I took from a scientific paper. In the upper left diagram, you see the reflectance of black anodized aluminum with a mirror-like behavior above 700 nanometers wavelength. Also, a black permanent marker should not be the solution of your choice. Well, that's a joke. The right diagram shows the performance of ACKTAR black direct coatings with reflectance well below 2% over the entire visible and near infrared wavelength range. So how can you make use of our technology? We have two options for you. Direct coating. The coating is directly applied to discrete components. It is done in a proprietary vacuum deposition process at our premises. A typical example is shown here in the picture. A lens housing with complex geometry. The second option is to use coated foils. They wear the same coating on a thin film substrate. Typically, an adhesive backing is added, and we supply you with sheets or customized pre-cuts and die cuts. Very easy to use. Before we have a look into some application examples, let's summarize the advantages of our ultra-black coatings. They are applicable for a wide spectral range for the UV, the visible, but also for the infrared, up to approximately 15 micrometers. They are highly temperature resistant and durable, and as they are applied in a vacuum process, they are applicable to most materials, most metals, glass, ceramics, and even temperature resistant plastics. They are totally inorganic and are qualified for demanding applications such as space, ultra-high vacuum, and cleanroom environments. They are relatively thin and a very reliable coating thickness. They are highly conformal to sharp edges and complex geometries, and that makes them especially useful for optomechanical components such as apertures or lens housings. There's no fluorescence, and for sure we fulfill rows and reach regulations. In the SEM images here on the left, you can see how our coating works. We create a surface morphology from a composition of metal-metal oxide structures that lead to a high specific surface area, and with that to a sliding refractive index from the medium air typically into the coating itself. As already said at the beginning, we are active in various markets and applications. Here is just a partial overview. Wherever light is generated, shaped and detected, there is always light that disturbs and is undesirable. ACKTAR black coatings suppress and absorb the scattered light, and with that enhance the performance of the optical system. Now, let's have a look into some application examples more in detail. This application example is from a camera system and imaging system, and here the ACKTAR black coating helps to improve the image contrast. It prevents noise on the image sensor and allows better detection of objects. Using ACKTAR black coatings eliminates the straylight images of high contrast objects, as you can see here in a comparison image from the optical design software without ACKTAR black coating, with a conventional coating like anodized aluminium on the optomechanical elements, and on the right side optomechanical elements coated with ACKTAR black coating. The second application examples show typical elements from industrial optics. They are used typically for straylight absorption or straylight suppression. They are used in the wide wavelength range, in the UV, in the visible, also in the infrared. You can see sharp-edged diaphragms and plates. You can see glass coating on glass elements and on optical packaging. Blackbody radiators, laser energy meters, thermal and radiation detectors are also typical examples from infrared applications. On the third application example slide, we have as an example, a wafer level coating. We can apply our coatings also on glass, on ceramics, and even on processed silicon wafers. And there you can use them, for example, to increase the absorption of light and therefore to enhance the sensitivity of the final sensor element. For example, if you have infrared absorbing elements. Special coating types of ACKTAR are also suitable for photolithographic patterning, and they are compatible with etching as well as with lift-off processes. And with that, I end my presentation, but not without asking you to contact us by phone, by email, or LinkedIn. Give us your straylight problem. We want to solve it.